Okay, good morning. We didn't quite get to these last night. We ran out of time, so I thought this might be helpful to go through the mean difference when you have a paired and dependent sample for your problem set that you're going to be working on tonight or today and turning in tomorrow on Thursday. Okay. So what we're going to be doing here is now you've got these matched samples. And essentially what you're doing is you're taking the same sampling against the exact same element. So as a result, you get a pair of data values associated with the case or the element or the situation that you're making an observation about. And one of the examples at the end that I've got in the as far as an exercise that might be helpful to you is you have two appraisers who are looking at the exact same home, and you're doing 10 samples, and each one is doing 10 appraisals for each one of those homes, so that makes them paired and then dependent. Okay. Now the good news is that for this sort of dependent design, it's a little more accurate. Okay, or there's much less sampling error, somewhat less sampling error, and so that would, if you can get to a paired sampling, that's always good. If not, then we've got some other techniques that we talked about last night. Best way to do this is to go through an example. Here you have a Chicago-based firm that they're trying to decide whether to go with this United Parcel Express versus International Express. And so they're going to run a test, and they're going to send documents out to 10 different locations and see which one has the lowest or the quickest. They're going to figure out which one has the quickest delivery times. Okay. And the technique here is a little more straightforward than what we've talked about before, because you've got these paired samples and some of the formulas get a little bit easier potentially. I'll let you decide on that. We're going to use a P.05. It's a random sample. Okay. And here are the differences, okay, between the delivery time for each office. And then so what we're going to do is we're going to use that difference and create our testing via a couple of additional formulas that are going to be made available to you here. 10 offices from Chicago. Let's do the p-value and critical value approaches. Okay. We've got HO, the mu sub d. Mu sub d is the difference. D stands for difference between the two offices, between the two competitors. Okay. So you're testing to see if they're the same or are they different. HA says they are different because it's not equal to 0. Okay. We're going to run this at P.05, and we're going to compute the test statistic. The test statistic is basically all you do there is sum up the difference. Okay, the 7, the 6, and there's a negative number in there. Well, divide by the number of paired samples, which is 10, and you get 2.7. We're also going to create more or less a pooled standard deviation for the difference, okay, of the samples. And the way you do that is just sum up the difference between the difference for that exact data point or for that exact city, and then subtract it from the overall D bar. All right, you're going to square that up, divide by n minus 1, and you're going to come out with 2.9. So there are the formulas that you're going to be using for paired values. All right. And then you're going to develop your t statistic, okay, or your test statistic, and you take d bar minus mu sub d. You've got all this already pre-calculated. You've got the standard deviation for the differences. Divide by the square root of n, and you'll come out with 2.94. Let's go with the p-value approach first. All right, compute the p-value. You've got a t at 2.94, degrees of freedom of 9, and the p-value is between 0.02 and 0.01. What we did there is we just doubled the upper tail areas from the chart in your book. Okay, and because they're two-tailed. All right, we are going to determine whether to reject the p-value. If it's less than 0.05, we're going to reject h sub o, and indeed you're going to come in about 0.02, 0.01. So there is a difference. So you would go, basically the decision at this point is that one of the companies is delivering quicker than the other. Here's the critical value approach. Okay. You create your critical values, okay, on your distribution curve, and it comes out at 2.262. Remember to because you're doing it at 0.05, you got to divide by 2 on either side, t.025. Okay, and those are your critical values. And because t is equal to 2.94 and that's greater than 2.262, we are going to reject h sub o, which, as you might expect, is the exact same conclusion we came to before. All right, so the business decision is to select that company that has the best mean time overall. Okay, and the difference is significant. Here's an example that you'll want to take a look at if you want to try this out. You see down there in the green it's a difference in the mean of these appraised values. There's 10 homes, Shattuck and Bauer. Okay, and you'll just use the formulas that you had before to come to some type of decision as to whether or not there is a difference of opinion, okay, between these two appraisers. Thank you.